Number 4, from graphing polynomials. We're going to graph this and identify the x-intercepts and the y-intercepts. So doing this with a calculator, I recognize that each one of these terms contains an x, and I can factor out a negative 1/2 out of each term. So what value times negative 1/2 equals negative 1/2? Would be 1. I need a total of 3 x's. I only have 1. I have 2 more. What value times negative 1/2 gives you a negative 4? Positive 8 times negative 1/2 is negative 4. I need 2 x's, I only have 1. What value times negative 1/2 provides you a negative 8? That would be a positive 16. I need 1 x, and I already have it. Okay, I recognize here that I can factor. What multiplies to give us 16 and combines to give us 8? Positive 4 and positive 4, so this is x plus 4, x plus 4, and negative 1/2 x. So in order for me to find the x-intercepts, by the way, I have the same quantity twice. In order for me to identify the x-intercepts, I'm going to set each one of these factors equal to 0, and I'll solve. So I'm multiplying by the reciprocal, and I still end up with 0. So one x-intercept of the 3 occurs at 0. I'm going to take the second quantity and set it equal to 0. And I get negative 4. Now this is a double at negative 4. 1, 2, 3, 4. So here are my 2 x-intercepts for this problem. Remember that when you identify an x-intercept, like this is 0, 0, and this is negative 4, 0. For x-intercepts, the y's are 0. For a y-intercept, the x are 0. So if I plug in 0 for x into each of these terms, I end up with an answer of 0. So at this position, both accounts for the x-intercept and the y-intercept. Now for this particular problem, we are looking at a function that is odd. It's odd degree and has a negative leading coefficient. That means end behavior is up on the left and down on the right. So it's going to be down on the right and up on the left. So up on the left, and it's going to be down on the right. Now remember, this was a double. This was a double. And so at this position where there is a double at negative 4, it's going to bounce off. So it bounces off and comes back in. So this multiplicity, this multiplicity is an even multiplicity. It may be also described as a quadratic multiplicity.